A block of ice and dust, roughly the size of a city, is silently cutting across our solar system right now. We get one chance to see it, one flyby, then it is gone. Forever. We call it 3I Atlas, and this is only the third time in all of human history that we can say, with confidence, that thing we are watching comes from another star. Before 3I Atlas, we only knew two confirmed interstellar visitors. In 2017, we met one, Oumuamua, a weird cigar-shaped rock that shot through the inner solar system so fast that by the time we realized how strange it was already leaving. It did not look like a normal comet. It did not behave like a typical asteroid. It showed up, broke all our expectations, and disappeared. In 2019, another traveler arrived, 2I Borisov, the first interstellar visitor that actually looked like a real comet. It had a classic tail, a fuzzy coma, gas flowing off its surface. If you did not know better, you would swear it was just another icy rock from our own backyard, except it was not from here. And now a third traveler has entered the story. See 2025 N1 Atlas. The International Astronomical Union gave it a special label, 3I Atlas, the third interstellar object ever found. It was discovered on July 1st, 2025, by one of the robotic telescopes in the ATLAS project in Chile. ATLAS is a network of automated telescopes, partly funded by NASA, that spends every clear night scanning the sky for anything new, anything moving, anything that might one day threaten Earth. On the first night, 3I Atlas was just a faint dot near the bright band of the Milky Way in the direction of the constellations Serpens and Sagittarius. Nothing about that first picture screamed historic moment. It was just one more moving speck among countless moving specks. The magic started when astronomers did what they always do. They plotted its orbit. The more positions they measured, the stranger it looked. The path of this object was not an ellipse. Planets and regular comets, the ones that belong to the solar system, follow elliptical orbits, closed loops that go around the sun again and again. Some are almost circles, others are stretched like footballs, but in all cases, if you wait long enough, the object comes back. 3. Atlas did not play by those rules. Its path was a hyperbola, an open curve. On a simple diagram, a hyperbola is a line that arrives from infinity, swings around the sun, and then escapes back to infinity. It never closes. It never repeats. In everyday language, that means something both simple and profound. 3. Atlas is moving so fast that the gravity of the sun cannot grab it. It is not bound to our star. It is not a long-lost member of our planetary family. It is a visitor, just passing through, one time only. That is what the I in its name really means. Interstellar. See 2025, N1 officially became 3I Atlas, the third confirmed object from another star system crossing our own. From that moment on, the hunt was on. Telescopes all over the planet started to twist, tilt, and lock onto this one tiny speck of light. 3I Atlas is fast, very fast. It enters our neighborhood at about 60 kilometers per second, more than 200,000 kilometers per hour, much faster than most comets we know in the solar system. Around late October 2025, it passed between the orbit of Earth and the orbit of Mars, reaching its closest point to the Sun at roughly 210 million kilometers, about 1.4 times the distance between Earth and the Sun. Whenever something unusual crosses the inner solar system, the same question pops into everyone's mind. Is it dangerous for Earth? This time, the answer, based on precise orbital calculations, is no. 3. Atlas never comes close in any way that matters for us. Its closest approach to our planet is around 270 million kilometers, almost twice the distance between Earth and the Sun. On cosmic scales, that is not a near miss. That is a distant flyby. From our point of view, 3I Atlas is like a shy tourist. It visits our neighborhood, but it keeps a healthy distance. It dives through the inner solar system, leaves the faintest fingerprint in gravity and dust, and then slips back into the darkness between the stars. Once its interstellar nature was confirmed, 3I Atlas triggered a truly global science campaign. The Gemini South Telescope in Chile captured deep images of its coma, the bright cloud of gas and dust surrounding the nucleus, and of its growing tail as sunlight began to heat its surface. Spacecraft orbiting Mars, like Mars Express and the Trace Gas Orbiter, joined the fun, planning and taking observations as the comet passed near the orbit of the red planet. Even the Hubble Space Telescope and the James Webb Space Telescope were brought into the effort, turning their extremely sensitive eyes toward this distant visitor. Every photon we catch from 3I Atlas is more than just a spot on a sensor. It is a tiny data packet about what comets around other stars are made of. It is not just a fuzzy smudge in a telescope. It is a chemical message from another system, translated into graphs, spectra, and images on our screens. In control rooms around the world, teams spent long nights chasing that message. Light curves tracked how the comet brightened and faded. Spectra revealed which elements and molecules were present. Computer models tried to pin down its orbit, its mass, and its behavior. For the first time, humanity was pointing so many eyes, human and robotic, at one single, natural visitor from another star. That alone tells you how important 3I Atlas is for science. So what do we actually know about the body itself? We know that 3I Atlas is active. Its surface is venting gas and dust as it warms in sunlight. The coma, that luminous cloud around it, hides the solid nucleus and makes it hard to measure directly. But astronomers can work backwards, use its brightness and its behavior to estimate its size. Those models suggest a nucleus several kilometers wide, possibly 5 or 6 kilometers across, maybe even larger. That makes it much bigger and more massive than one ʻOumuamua or 2I Borisov. Here comes the weird part. Even though 3I Atlas is clearly outgassing, its orbit is almost perfectly described by gravity alone. In many comets, gas jets act like little thrusters, nudging the comet off its predicted path. With 3I Atlas, those non-gravitational kicks, if they exist, are tiny compared to its huge mass and momentum. Some studies suggest that, for the observed activity not to noticeably change the orbit, the nucleus must be extremely massive, equivalent to tens of billions of tons of material. In simple terms, 3I Atlas is an interstellar iceberg, big, heavy, and surprisingly stable as it plows through space. Another key clue comes from a satellite in space. The Swift Observatory, a NASA mission sensitive to ultraviolet light, detected clear signs of hydroxyl radicals, OH, surrounding the comet. Those radicals form when sunlight breaks apart water molecules. This is one of the classic fingerprints astronomers use to say, "There is water here." And Swift did not just see a trace of water, it saw enough to suggest that 3I Atlas was releasing dozens of kilograms of water every second, even when it was still almost 3 times farther from the sun than Earth is. How is that possible? The most likely explanation is that the comet is spitting out tiny grains of ice. These grains drift away from the nucleus. Out there, even faint sunlight is enough to slowly turn them from solid ice into gas, building a wide halo of water vapor around the comet. It is as if 3I Atlas were traveling wrapped in a cloud of floating snow, melting in slow motion as it passes through our part of the solar system. Then came another twist in the story, a radio detection linked to that same water. Radio telescopes like Meerkat in South Africa detected specific radio emission lines from hydroxyl in the coma of 3I Atlas. It was the first time we had ever picked up this kind of radio signal from an interstellar comet. Of course, the internet did what the internet does. A strange radio signal from a visitor from another star? Could it be artificial? But the pattern matches what we see in normal comets right here at home. When sunlight breaks water apart, OH can emit radio waves at very specific frequencies. That is exactly what was measured. No alien beacons required. Nature, once again, is wonderfully weird all by itself. Even so, there is something beautiful about the idea. For the first time, we are listening, in radio, to the whisper of water from another star system. So where did 3I Atlas actually come from? If we roll its trajectory backwards, it appears to enter from the direction of the constellation Sagittarius, near the center of the Milky Way. That does not mean it was launched from the black hole at the core of the galaxy. It simply means that somewhere in that patch of sky is the star system that once hosted this comet. Using data from Gaia, the European mission that maps positions and motions of more than 1 billion stars, astronomers have tried to find a particular star whose path might have crossed that of 3I Atlas in the distant past. So far, no definite home star has been identified. The most likely story goes like this. 3I Atlas was born in the cold outer region of another planetary system, in a dark reservoir of ice and rock similar to our own Oort cloud. Out there, trillions of icy bodies orbit their star for eons. At some point, a close gravitational encounter with a giant planet, something like a distant Jupiter, gave this comet a powerful kick. It was thrown out of its home system at escape velocity. From then on, it spent hundreds of millions, maybe billions of years, free-floating in interstellar space. No star, no planet, just darkness and time, until chance brought it into the tiny zone occupied by the sun and its planets. This journey has lasted longer than our entire species has existed, and maybe longer than any complex life on Earth. What does 3I Atlas tell us about other worlds? One of the biggest questions in planetary science is whether our solar system is normal or strange. 2I Borisov already hinted that other systems might produce comets much like ours. Its chemistry looked surprisingly similar to that of our long-period comets. Now 3I Atlas seems to bring familiar ingredients too, especially water and other volatile compounds. If interstellar comets keep looking normal, that suggests that the disks of gas and dust that build planets might behave in similar ways around many different stars. And there is an even bigger idea hiding inside this. If icy objects like 3I Atlas, packed with water and complex molecules, are constantly being thrown out of their home systems, then the Milky Way is full of wandering seeds, small packages of chemistry drifting silently between the stars. We are not necessarily talking about living cells hitchhiking across the cosmos, but something more subtle. Organic molecules, carbon, water, delivered again and again to young planets in different systems. Across billions of years, how many times have comets like this donated raw materials for life to alien worlds? We do not know. But every interstellar visitor we catch makes that question feel a little more real. This story also forces us to turn the camera back on ourselves. Think about the timescales. 3I Atlas might have been kicked out of its home system billions of years ago, when Earth was just a bubbling ocean of lava, or when life on our planet was nothing more than simple microbes. While continents rose and sank, while dinosaurs appeared and vanished, while mammals and humans evolved, this comet kept drifting through the dark unseen, unmeasured, unnamed. Only now, for a brief window of a few months, a species that built telescopes, satellites, and worldwide data networks is finally able to notice it, name it, and read the light it sends our way. Then it will be gone. It will fade from our sky and continue on its path, probably never coming close to another civilization again. In that tiny overlap between its story and ours, there is a powerful question. Imagine another civilization, far in the future, trying to reconstruct the history of our solar system from just a few clues, chemical fingerprints in the atmosphere, fragments of probes, rings of space junk in orbit. What would they conclude about us? Maybe they would see rusty spacecraft circling a quiet planet. Maybe tangled belts of metallic debris and trapped radiation. Maybe a thin chemical scar in the air, evidence of an industrial era that flared up and ended. They would be doing to us what we are doing now to 3I Atlas, studying a faint trail of matter and energy, and trying to read an entire story from almost nothing. Interstellar visitors like Oumuamua, Borisov, and Atlas are not just cool headlines, they are mirrors. They remind us that we too are brief travelers. We pass through a tiny slice of time in a universe that existed long before us, and will continue long after we are gone. 3I Atlas will keep going. Millions of years from now, it will still be out there. Just another frozen fragment wandering between the stars in perfect silence. We, on the other hand, still have a choice to make. We choose, every day, what kind of trail we leave behind, in our atmosphere, in our technology, in our signals, and in the way we treat the only world we know for sure can host life. So the most interesting question is not just, what is this comet made of? The real question is, when someone, somewhere, someday looks at the faint traces of our own system, what story will our trail tell about us? And if questions like that keep you up at night in the best possible way, then stay with us, because the universe is not just full of answers, it is full of curious facts and even better questions.